Just a
So,
second, ma'am. Yes, ma'am, your screen is visible, ma'am, and you can start.
okay, so last class we did till the heat capacities for the various process, right? So I guess everyone remembered these concepts, and today we will be learning with start with the degrees of freedom. Okay, so today we will be starting with the degrees of freedom. Degrees of freedom. So from last class, does anyone have any doubt? Anyone, any doubt or anything you want to ask me? No? No one wants to ask me anything? Okay. So let's start with degrees of freedom. So what is this degree of freedom? Does anyone have any idea? Same thing you will be learning in the physics also, physics class also. So actually degrees of freedom, this actually represents the number of ways, means the number of ways three through which, wait, sorry for the interruption. Okay, so it represents the number of the ways through which a system can change from one state to another. So represents number of ways by which one state or through which one system can change from its current state. Okay, so this is the standard definition which is given by books. So this is something like what I can say, transitional kinetic energy, rotational kinetic energy, vibrational energy, which involves kinetic energy and potential energy. So actually, if I say that there are three types, okay, so there are three types. What are these types? One is the transitional kinetic energy. Transitional kinetic energy. Okay, so it occurs at all temperatures. All temperatures, remember. Second is the rotational. You will be learning about these details in the physics, but just for sake of knowledge, learn about this. Rotational kinetic energy. This occurs at moderate temperatures only, specifically moderate temperatures. Okay, and thereafter comes the vibrational. What is the vibrational? This involves the kinetic energy and the potential energy. So it involves the kinetic energy along with the potential energy. So it occurs only at very high temperature, strictly. So total degree of freedom. So degree of freedom we write as DOS. So the total degrees of freedoms are, what is the total degree of freedom? So that is obviously 3n. What is n? N represents the number of the atoms in a given molecule. Okay. Number of atoms in a given molecule. Okay. So now this is the bookish definition or the theory for the degrees of freedom. But now we will be learning how this will come for your exam. How this will be coming for your exam. Okay, so how will this come? Suppose they will be asking you find degrees of freedom for helium, hydrogen. Anyone can try while I'm writing the question. Carbon dioxide, not carbon dioxide. Water. Then suppose ammonia. and C2H6. So anyone wants to try this? Something you need to know for this is this. This is a trick. Translational. Translational is 3 for all. Okay. Then for rotational. Rotational is 0. Just wait for 1 minute. Just wait for 1 minute. Sorry for the interruption. For rotational, it will be 0, 2 for di, tri, linear or linear, and 3 for poly. Okay, and vibrational. Another is the vibrational. It is 0 for mono. In last page, whatever I have written for the degrees of freedom, that will be coming for boards. This will be coming for your exam. Okay, so di, tri, which is the linear. Same, it is a hyphen. And then, so it will be poly. So now, does anyone want to try for helium? What will be it? Just try. Just try and let me know. Unmute yourself and try. Just unmute yourself and try.
For helium, transitional kinetic energy.
Yeah, someone was saying anything?
For helium, transitional kinetic energy.
Yeah. So helium, you want to say it will be 3. Good. See, so the degree of the freedom for the molecule is the number of independent ways it can move or rotate. Okay. So helium, for helium is 3. From here it is coming. Okay, wait, I'm writing. So it will be 3 from here because 3 is for all, then 0 and 0 because it is a homo, it is a mono. It is not di, tri or anything. I have written for di, tri what you have to consider. So it is 3 plus 0 plus 0. And I guess you know how to calculate. For hydrogen now say, what will be the answer? Hydrogen, what will be the answer? Try.
2
It is
plus
easy.
3n minus 1 minus 5.
Ma'am, 5.
No, it will be
3n,
6.
3n minus 3, sir. Ma'am.
Yeah. So it will be 6. Okay. So for water, what will be for water?
Two, ma'am.
No.
Ma'am, 6.
No. Okay, water should be 9. I am telling you this. For hydrogen, did you understand? I guess here you have the problem. So for hydrogen, I've seen for translational, it is for 1. So you have to add 3. Okay. Then 2. Because water is a what molecule? Hydrogen is a linear molecule.
Diamol.
Yeah. Hydrogen looks like this. Himanshu sir has taught you about chemical bondings.
Yes, ma'am.
Oh, so why are you like doing this type of thing? Okay, so it is 2. Okay, from there it is coming 2. And for vibrational, what is for vibrational? It will be, see, 3 into 2 minus of 5 here. Why here? Because here it is written di. Okay, so here it will be 3 into 2 minus 5. 6 minus 5 is 1. So what will be here? 1. So it is coming 6. Did you understand now?
Yes, ma'am. Yes, ma'am.
Take a screenshot of this page. Or this is for hydrogen. This is for hydrogen. Helium is simple, just this.
Ma'am, once can you explain again hydrogen?
Hydrogen, okay. 3 is from here. Okay, wait, I am using another pen. 3 is from here. Okay. I told you to write 3 for all. Next, hydrogen is linear molecule. We all know this. Hydrogen is a linear molecule. Linear and it is a di. Okay. This is the structure for hydrogen. And hydrogen here, see 2. So it is di. So I will be writing here 2. Okay. Now, for vibrational, again it is di. Okay, it is di. Why? Because here it is written 2. From there we can know. And for the 2, what I have given the formula? 3n minus 5. N is what? N is this 2. So 3 into 2 minus 5. This is 1. So ultimately from here 3 plus 2 plus 1. It is 6. Is this part clear? Now? Yes or no?
Yes, ma'am.
Everyone clear? Now just try the water. Why it is I am saying that it is 12. Just try for water. Remember this, that whatever I taught you in the last page is for your boards. This is for your joint or whatever exams you are giving, competitive. And this will come most probably either in you can see in your physics part or your chemistry part. So now try this water. Okay.
Ma'am, is it 9?
No, 12. How it is coming 9? First here, 3. Okay. Then it is a non-linear molecule. See, this is a non-linear. Poly means non-linear. Consider it to be a non-linear also. Okay. So water kind of looks like this. Okay, so this is, I'm not drawing all the bonds, but just to make you understand that water has a structure like this. Okay, so I can't consider water to be linear, and water is not homo, right? It is not a simple molecule. Why water is not a simple molecule? Because this is not simple like hydrogen. Okay, so here water is like kind of a bent structure. So what we will consider? We will consider this 3. So this is 3. Okay, now, so we can't use this formula. We can't use this formula. We will be using this formula. Okay, so what will be the formula for this? This will be, how much is this here? 3
0.
into 3 minus of 6. Now you will be saying, why ma'am 6? Here you have written 2, here you have written 2, 3. It is 2 and here hydrogen is 1, right? So 2 plus 1 is equal to 3. So I have written this as 2 plus 1. 2 for hydrogen, 1 for oxygen. Okay, is this part clear?
Yes, ma'am.
Got it? So what is this?
3, ma'am.
Wait.
Same.
Yeah. So what is this? How much it is coming? 3. So again 3.
9.
Yeah, so 9.
Nine.
Yeah, sorry, someone told 9 and I made the mistake. So is this part clear how we are calculating for water?
Yes, ma'am.
Okay. So now tell me ammonia.
12, ma'am.
Oh, okay. Before this, take a screenshot of this page. How to calculate for water. Done. Now I will be giving you 2 minutes. Now tell me for ammonia.
12, ma'am.
12, ma'am.
12. Sure.
Ma'am, it is 13, ma'am. 13.
How it is 13? Now there is an imposter in our class. 12 is the correct answer. Now ammonia, for ammonia it is 12. Now how 12? Okay. Let me erase everything.
Yes, ma'am, it is 12.
So do I need to explain or anyone will be explaining it to me? Okay, I'm explaining. So why is ammonia 12? Suppose this 3 is coming everywhere. Okay. So for this 3, then for non-linear like this, ammonia also kinda look like this. Okay. I'm not drawing this lone pair and everything. I'm just drawing the overall structure. So basically, you know which is linear molecule and which is non-linear molecule. And if it is linear di use this. If it is non-linear, just use this. Okay. So NH3, so this is coming 3 also. Now, which formula we will be using? This. So it will be 3 into 4 minus 6 because ammonia this 3 and here it is 1. So plus 1 is 4. It is 6, I guess. So it is 12. Is this part clear?
Yes, ma'am.
Yes, ma'am.
Okay. Now say for C2H6. What is C2H6? C2H6 will come a huge number.
Ma'am, it is
24.
24. 24, ma'am.
Yeah,
24.
very good. Everyone understood how it is coming 24? Everyone understood how is it coming 24? Is there anyone I need to explain that why it is coming 24? No? There is no need to
No,
shy.
ma'am.
There is no need to shy even if someone has not got this answer. Okay. So let's move. So degree of freedom done. So if question comes from degree of freedom, will you be able to answer?
Yes, ma'am.
Okay, good. Then comes law of equipartition of energy. What is this law? Again, this is something, this entire chapter you will be learning in physics also, because, but only the signs will be ulta or the reversed. Whatever signs we are using here, plus minus, there you will be using different kind of this sign. Okay, so this is again something interesting. Again, something like kind of maths like. Okay, so what is this? What is the, so according to it, energy is distributed among various, so energy is distributed among various degrees of freedom. This is the standard bookish definition that can be asked in your boards equally. Okay, so this is for standard definition. So for translational DOF, energy associated with each transitional DOF is half kT of the molecule. Okay, so let's write here. For translational degrees of freedom, what we have to do for translational degrees of freedom? Energy associated with each translational DOF per molecule. Always remember this. We also always consider it per molecule. So that will be half kT. Okay, so half kT of molecules. We will be learning how to do this. For now, just listen. Energy required, again, energy required, or you can say energy associated, whatever, with each translation, all will be same with each translational DOF, but here it will be per mole. You know what is the difference between mole and a molecule from the first chapter?
Yes, ma'am.
Good. So half, so here I have already written, so no need to write here again. So here it will be joule per molecule. So it will be joule per molecule. Here it will be also joule per molecule. Okay, so this is the basic formula. So if translational, okay, now if there is another thing, if translational DOF are represented as FT always, okay, then the total energy associated with FT number of, here I am writing, therefore total energy associated with FT number of translational DOF per mole. Okay, this represents per. What will be the formula? FT RT by 2. Something joule per molecule, joule per mole. Okay, so up to this, is it part clear or not? Just see. This is the definition and the example, definition and the formulas. Is this part clear to everyone or not? Clear, everyone?
Yes, ma'am. Ma'am, I have doubt.
Any doubt?
Energy required with each transition DOF per molecule when we use the thing.
Yes, these are the standard formulas. Just remember this for now. Done. Okay. Now let's dig up with some other formulas. The same thing you will be learning in your physics also. Okay. For rotational degrees of freedom. What is this? It will be exactly same as before. Remember, Okay, I'm not writing this. This is how you will be reading your notes also. But for vibrational DOF, degrees of freedom. Energy associated with each molecule. Energy associated with each vibrational DOF per molecule. What will be the formula? The formula will be kT only, no half and anything. Joule per mole. And energy associated with each vibrational DOP per mole. What will be the formula? RT. Joule per mole. Is it okay? Now, is it done? Is it okay?
Yes, ma'am.
Okay, wait. So, coming for internal energy which is present within a system for 1 mole. U is equal to half, not it. It will be FT RT by 2 plus FR. R means rotational, okay? The rotational degree of freedom. RT by 2 because FT and FR is basically the same, plus FVB. VB means vibrational RT. So this is the standard formula, okay? This is the basic formula for internal energy for 1 mole. So you can write it like U is equal to FT plus FR plus 2FVB into RT by 2. The same formula can be written like this also. I've just considered it like I have multiplied everything by 2, okay? So this gets cancelled and only for here it is coming 2. Is this part clear? Now.
Yes, ma'am.
So this you can also write as CVM. Last class we did. So CVM is FT by 2 plus FR by 2 plus FVB whole of R. Okay. So CPM, this is CVM plus R. Okay. And gamma, if you have gone through the last class, it is CVM, not CVM, it is the ratio, sorry. It is the ratio, it is CPM by CVM. Okay, so these are the formulas you will be learning. Now, this is for your boards. Okay, this derivation is for your boards. They will never ask this definition in your exams. This is for your boards and how this CPM, if they ask you derive the formula for CVM, derive the formula for CPM, just do like this. Okay, this is the formula for your boards. Now, what will be coming in your exam? Again, what will come for your exam? find out CPM, CVM, and gamma for number 1, helium, which is in gaseous phase. Number 2, hydrogen, gaseous phase. Number 3, carbon dioxide, gaseous phase. Number 4, water, gaseous phase. And finally, ammonia. It is also in gaseous phase. Now calculate and tell me if you have really understood CPM, CVM, and gamma. How much did you understand from this? I want to see. Just try once. It is not like something you have to do. Just try, I am here to explain. Anyone? You need the formulas? These are the formulas. Yeah. Copy this formula and just tell me. Okay. Huh. No. So for in this page, let's delete the other options. Okay. For now, just learn about helium. Then you will be pro. Like you are a pro in a degree of freedom now. You will be pro for this also. And this. Helium, what is helium? Monoatomic gas? True or false?
Yes.
True, ma'am.
Yeah. So what is the degree of freedom for helium?
3,
3, ma'am.
3, ma'am.
3.
Good. It is 3. So it's vibrational and other things. So what
0.
is vibrational? Fa and FUB. It is 0. We know this. We have just learned this. So now just replace it in this formula. What is this formula? A huge formula. Right. What is the first thing you have to calculate? CPM. What is CPM? FT by 2 plus FR by 2 plus FVB into R. What is R? You will be learning in your senior classes again. Okay. Not senior class, in your class, in the other class only. Okay. So what is this FT? CPM and CPM? Now tell me, what is this FT? FT is 3.
3 by 2, ma'am.
3 by 2.
By 2. What is FR?
0. 0.
Is it okay? Similarly, now tell me what is CVM.
Excuse me, ma'am.
Yeah,
CPM is equals to CVM plus R, na ma'am.
yeah,
Formula.
yeah. So they use that formula only. If
Then
you
give
want to
me
use that
that
long
formula.
formula also, it is okay. It is okay. And gamma is what? CPM by CVM. So is this part clear how to calculate CPM and CVM? Is this part clear? Everyone? So what is CVM? What is CPM? Use the formula here. Either use this formula or CPM is CVM plus R from that formula is equal. Also you can use. See, this formula also you can use. Or you can use that formula also. It is CVM. Sorry, it is CVM. Sorry, it's my mistake. It is CVM. So what is CPM? CVM plus R. So it is 3 by 2 R plus R. What is this? How much it is coming? 5 by
4
2.
by 2.
5 by 2 R. So what is this? 5 by 3. So is this part clear how to calculate this CVM, CPM and everything? Is this part clear? Everyone, is this part clear?
Yes, ma'am.
Now calculate for hydrogen, CPM, CVM and everything. That is the reason I have taught you the degrees of freedom first. Hydrogen. I will not say you anything. You know the basic formulas. What is CVM? That CVM formula? CVM is FT
By 2.
by 2. Sorry. FT by 2, then FR by 2, then F of vibrational into R. What is CPM? CVM plus R. And what is gamma? CPM by CVM. Now just tell me the answer. I just want to know the answer. You know the degrees of freedom, you know how to calculate everything. Just tell me the answer. Just tell me the answer. Then I will be telling you one more thing. Okay. Just tell me the answer. Tell me, tell me, tell me. Can you do it? So, what is the FT for hydrogen? Hydrogen is a diatomic gas. Diatomic gas. You just
Okay.
need to calculate the degrees of freedom first, right? So obviously it has three and three translational. So FT is 3 for it. 2 rotational Okay, 2 rotational degrees of freedom, that is, and 1 vibrational. Okay, that formula 3n minus 4, using that formula. Okay, so total degree of freedom is 6 for hydrogen. Now use this formula CVM. What is FT? 3 by 2 plus 2 by 2 plus 1. Calculate. CPM is whatever you are getting plus R. And this is the ratio. Simple. Is this part clear? It is, I guess, coming 7 by 2. It is 7 by 2 R plus R. How much it is coming? No, it is coming 5. It is coming 5. This is 5R by 2. It is coming 7 by 2R. And then just the ratio will be coming as 7 by 5. Just calculate the degrees of freedom, rotational, translational, vibrational, as far as I have told you, and then you will be getting the answer. Is this part okay to everyone? Just you need to calculate the degrees of freedom. Now, is this part clear?
Ma'am, CVM is 7 by 2 R only.
Yes, yes, you can. I have not done it exactly, but you can be doing like that.
7 by 9, ma'am. Gamma.
Yes, good. So for your home, you can now one more thing I need to tell you. So just choose the molecules and you just practice. That is what you have to do. I'm making a chart. Atomicity. Then FT. Here comes FR. You can remember this or you may not remember this. No problem. This is something I need to draw a conclusion. That is the reason I'm dealing. CV, CP, gamma. Mono, di, and tri. For mono, it is 3, 0, 0. We know this. So it will be 3R by 2. It will be 5R by 2. Now you have done the chemical bonding, right? So if you know the structure of this formula and you remember this chart, obviously it will be, you don't have to calculate also. You can see this chart and answer. Okay, so for di, what is for di? For di is 3, here it is 2, here it is 1. And here it will be 5R by 2. Okay, this will be 3R and this will be, sorry, this will not be 3R. This will be 7R by 2. And here it will be 7 by 5. Here, for tri, you will be getting 2 things. Linear molecules and the non-linear molecules. You will be getting 2 things. Okay, so accordingly learn. So it is 3, here it will be 3, here it will be 2, here will be 3, 4, 3, it will be 5R by 2, it will be 3R. So it will be 7R by 2, Here it will be 4R. And it will be 7 by 5. It will be 4 by 3. So this is the basic chart. If you calculate the degree of freedom for everyone, you will be seeing that this is coming. Okay. So this is coming. So if you just know the structures of the molecule, you can know CP, CV, you can know their degrees of freedom, you can know everything. I have written whatever we have learned so far in a chart form. Okay, so this is something we
Ma'am,
have
I have a
already
doubt.
learned. Huh?
I have a doubt.
Okay, good. So, yeah, so see, atomicity here is increasing. Mono, di, tri, right? Atomicity is increasing. But what is happening here? Gamma is decreasing. This is a very important conclusion. Atomicity increases, gamma value decreases. This is something that you can relate in your periodic table. It was not written in the periodic table. I have not mentioned because I need to mention here. Okay, so this is atomicity. As atomicity increases, gamma decreases. Is today's class clear to everyone? Because suppose they give you example like helium, hydrogen, then water, and have asked to calculate gamma. Or maybe this is the very basic example. They have given you more complex examples where you know which is mono, di, tri, and accordingly you have to calculate gamma. Are you going to calculate gamma for each of them? No, you know. More the atomicity, this is 3, this is 2, this is 1. You know, more the atomicity, less will be the gamma. Just check those options and write. Now, if all of your 4 options, they have set this rule that gamma is decreasing for, gamma is less for this. Okay, then you have to calculate. But if you already know that in rest 3 other options you are seeing that the order is not correct, okay, so then you can obviously just see and answer the question. This is how you save your time and eliminate the options. Is this part clear? Is this part clear, how to eliminate the options and how to answer the questions more fast? Is this part clear? Now,
Yes, ma'am.
yeah, whatever I have written here, if you don't trust me, you can just calculate everything. I have just done the calculations and have given you the chart. But for your boards, obviously they will ask you how it is coming. So that is the reason I have shown you the detailed process. This is that one detailed process. This is another detailed process. So this is the degree of freedom and the equipotential energy for everything. So is this part clear? How you have to solve in your boards, how you have to solve in your this thing, NEET, IIT exams, JEEs and everything. So is this part clear? Everything?
Yes, ma'am.
Okay, so now we are going after 2 classes. We are learning about parameters related to first law of thermodynamics. Finally, first we will be learning about the parameters. Okay, after learning this, and after doing your physics thermodynamics, don't ask me that, ma'am, you have taught us completely wrong, because whatever science I will be using in chemistry, just the reverse you will be doing in your physics. They have their own logic. We chemists have our own logics. Okay, so it is just opposite or reverse. Now, what is work first? Work is W. What is work? Transfer of energy due to pressure difference. This is bookish definition or your board's definition. Transfer of energy due to pressure difference. Okay, so it is neither intensive nor extensive. Remember these points. Neither intensive nor extensive. And one more thing, it is a path function. It is a path function. So, what are the types of work? Types of work. What are the types? PV or expansion work. In your class 12th, I won't be saying why I'm using PV, why I'm not using PV. That is the reason I'm writing here in extreme details. Non-PV work. Okay. This is something not present in your books. But for numericals, how you will be understanding where to use PV, where not to use PV, that is the reason I'm writing. Like muscle work. Muscle work. Or electrical work. Okay, this is the thing. So in the first law, we mainly deal with PV. Very important statement. For chemistry, for first law, we deal with PV or expansion work. Most of the cases. Expansion work in most cases. So almost I have told you how to solve your numericals. For your chemistry. So now sign convention. Very important. So is this part clear? First part, is it clear to everyone? First part, is it clear to everyone? Now we will be learning about the sign convention. How is the sign convention done? Sign convention. Work done by system or work of expansion. Work done by the system or work of expansion. You should take this value as negative. Okay? And work done on the system or work of compression. Work of compression. Okay. So this is something you will be taking as positive. So suppose I have given you an example of what does this mean? What does this mean? It is by the system. Negative. Negative means work done
On the system.
how on? On is plus. Here
By
it is
the
by the
By
system.
the system.
The system.
This means system is expanding. Okay? This means system is expanding. Is this part clear so far? Clear?
Yes,
This is
ma'am.
your
Yes,
sign
ma'am.
convention for work. Now we will be studying something for our boards. What is this? Calculation of work. How we calculate. This will come in your boards. Calculation of work, derivation. Okay. So suppose I'm drawing here. This small part. Okay, so for okay, so this is something, this is a huge derivation, and I guess you have another class, right? So we will be resuming this from next class. So tomorrow sir will be taking the class, okay? Let's resume this class. So sir will be taking the class, okay? So from the, please join the other classes.
Yes, ma'am. Thank you, ma'am. Students, you can join next class. The chemistry link which I have sent, please join 7 to 8 link. Sir will take